Hi guys, this video covers the solution that I've developed for the first example of the Lecture 8 section on process troubleshooting. So for this problem, we're looking at this slide 6 within the lecture series, which states that a packed absorber is designed to reduce acetone concentration in air from 0.02 to 0.001, this being a mole fraction, using water as an absorbent coming in at 20 kilomoles per hour. So after operation for a time, it's found that the acetone concentration in the outlet, or leaving with the air, has risen to about 0.008. So this is showing an issue of an off-spec air outlet stream. So let's take a look at this in terms of using the process troubleshooting strategies to develop an effective solution. So following the Fogler and LeBlanc method is what I plan to use for most of these examples. So I'm going to adjust my screen so you can take a look. So we have an acetone absorber that is off spec. So this is our problem. So step 1 is done. Step 2 is to generate causes and effective solution strategies. So following this, there's a lot of ways in which this acetone absorber can come off. Looking at our absorption equation, we know that the absorption is directly proportional with our liquid feed rate, and it's indirectly proportional with our gas flow rate and our partition coefficient. So following this, we can brainstorm a whole lot of ideas in terms of ways in which our outlet concentration in our air can come off spec. So, for example, if our gas flow rate increased, then Y out could increase. Also, if our liquid flow rate, or utility, with this being water, decreased, that would also be the same. I'm just using quotations to kind of show, ditto. Another idea is if our partition coefficient increased, that would also result in a Y out increase. Therefore, we have to think of various ways in which each of these three variables could be modified. Now, I do want to note, you can argue issues in terms of number of stages. However, for most plants, it's very rare for something theoretical like that to be a true cause. And I'll write that down. However, you can say, channeling, packing issues, you have Rashleigh rings or things like that that's kind of fallen out of alignment. And fouling, if applicable. But when I'm looking at air, acetone, and water, there's not really any way that those three components, as described in the problem, can really generate fouling. And so if I were to focus on the first three issues I'd identified here, I can ask myself, okay, what are ways in which this three values can change? And what's an effective solution to address each of three variables, right? So what's my solution strategy? So how am I going to, quote unquote, fix it? Right? So there's a lot of ways that you can do this. And it's important. I want to emphasize that for a lot of these problems, there's no one solution. There's a lot of varying effective solutions. The key is that as you write up your solutions, they're organized and they follow a logical pattern and an effective strategy. If it looks like you're just listing things, I'm going to have more issue in terms of your solution, and especially on the test. I want to be able to see, okay, what's the problem? I also want to be able to see, all right, you're using step 2. I want to see, okay, you're developing a solution. You're moving on to step 3. I want to see you using the steps effectively to develop your troubleshooting strategy. Hopefully that makes sense. So a good solution strategy. So my stuff's off spec. I want to get it fixed. Well, if I want to just treat the symptom, I would simply, if possible, increase my water flow rate until Y out goes back into spec, if possible. If not, my other option, knowing my partition is a function of my partial pressure, and knowing that I don't want my partition value to go up, I could then increase my tower pressure to make the acetone favor the liquid phase. However, that's my second option, primarily because increasing the tower has implications associated with it's generally a more hazardous situation the higher your tower pressure is. And sometimes the towers are going to be rated for only moderately to low pressures, depending on what you've built it out of. And so that's why I have that on my second option. A lot of times it's a lot easier to just increase the water flow rate. It's going to be a little more costly, but it's still, a quote unquote quick fix. And so the second step, once I have treated the symptom, I can identify the cause. Which is, the question is, well, then how are you going to do that? Well, you can inspect the air feed for discrepancies, right? So is Y in too high? Is my flow rate too high? Right, so I'm going to look at that feed coming in and ask myself, is it coming in a way that I expect? Then what you can do is you can inspect the tower. Do you have evidence of channeling? Or do you have any sort of evidence of process variation? Meaning, if you went to the control room, are things acting a little wonky? Has your pressure been changing? Has your outlet flows been fluctuating a lot? Things like that. And at the same time, if you want, you can also inspect the cooling water. Now, inspecting the cooling water is a little harder. That's why I put it down on 3, because the temperature is going to fluctuate. It's not like you're going to put a heat exchanger to regulate cooling water coming in from a utility. The water is what the water is. Generally, you assume a certain temperature. It's probably going to fluctuate. Thus, in the summer, you could expect your cooling water to be hotter than the cooling water that you're going to probably be using in the winter. But there are ways to encounter that, right? So do you have issues with flow? So is your flow rate off? And is your temperature off, right? So this is a good solution strategy. Hopefully you're starting to see what I'm doing in this process troubleshooting problem. I've defined the problem. I've kind of looked at the various phenomenon associated with this absorber, narrowed it down to a few potential causes. Once I've got those causes, I've then developed a strategy, right? I treat the symptom one or two ways, and then I've developed a few causes that I can then investigate to see if those are the cause, and then fix as needed. So then fix issues as needed. What I mean fix issues as needed is if your flow rate's off in the cooling water, figure out why it's off. Is it a valve issue? Does the valve need to be replaced? If there's channeling, you can determine whether it's something that you can fix quickly or you're going to have to do some updates on a next scheduled maintenance, right? Because if it's going to be moderate channeling, it might be better and cheaper to just increase the cooling water until you get to the next scheduled maintenance. Then once the maintenance in the plant shut down, then you go in and address the channeling, and then you can reduce the cooling water back to the normal rate. Well, thanks guys. That's the solution for this example that I have. I know it was a little long-winded, but I wanted to kind of go over and explain the situation in great detail to give you guys a lot more information